Hi, this is Daniel Goddard, and this is the presentation project for geophysics. And this is a solo one on geothermal exploration near the Salton Sea. Starting with some background information about the Salton Sea. Originally, it was called the Salton Sink and was an area that people wanted to farm. So they had the idea of bringing in water from the Colorado River to bring in controlled flooding for agricultural purposes. However, once they started this project, pretty early on, there was a lot of increased raining period in the Colorado River, and it would expand up to 3 times the size, which caused a large flooding across it. And notably in the 70s, the entire area was flooded and became a large lake, which is what it more or less is today. This became a large area for wildlife and recreation. Even though the entire thing sits on the San Andreas Fault, so it's always the risk of seismic activity, as well as the other geothermal properties all that go on with it. The current state of the Salton Sea, starting back in the 90s-ish, the lake kind of became too salty due to things like drought, lack of rain incoming into the Salton Sea. The water levels were decreasing, and the lake, and since salt doesn't decrease with the evaporation, the lake quickly became much saltier. It's even saltier than the ocean by this point, and this causes a lot of fish die-offs, as well as killing a lot of birds that were using it to migrate. But importantly, the fish die-offs caused these dead bodies to sort of accumulate in areas that had once been underwater, but were no longer underwater due to the lowering water level of the Salton Sea. And this caused a very large smell problem that could be smelled throughout like a vast hundreds of miles, like 100 miles or so within the area. And when the people were petitioned to do something about it, they decided that burning it would be the best course of action, which spread toxins throughout the air and caused human health hazards. And then that caused more initiatives to be started to try and do something about this problem that had become the Salton Sea. Another problem that was associated with it was algae blooms had been going off in it due to fertilizer being run off into the Salton Sea. Since the Salton Sea has no outlet, water just ends up there and dries away. Since the area can get very hot. Geothermal power is widely used in the area today, and there's over 10 power plants generating 620 megawatts of power distributed across Imperial County and Mexico. Some of the earlier proposed ideas are to use an aqueduct to import ocean water, strangely enough, for the purposes of desalinization plant, powered by the geothermal power plants, which they'd be able to sell the fresh water and also try to rebuild its farming past. Of course, the geothermal activity there leads to volcanism. Numerous mud pots and mud volcanoes, depicted as a mud pot up here, mud volcano down here, are found throughout the eastern area. Specifically, they show a sign of clustering, as in they are primarily found along the Putative Wester Fault, which is locally known as the Sand Hills Fault, sort of a minor fault near the San Andreas. These mud pots have the unusual gas emissions, including CO2 emissions. Their size is typically 0.5 meter to 3 meters deep and 0.5 meter to 10 meters in diameter. And they're found throughout the Salton Trough, which is sort of the area around the Salton Sea now. General Motors, interestingly enough, announced a partnership with Controlled Thermal Resources, which is a company that it owns the geothermal power plants. And they are looking at the possibility of extracting lithium. Actually, they have started to build up the infrastructure needed to extract lithium from the Salton Sea. Since the Salton Sea sits on a loose deposit of lithium, this was loosened, of course, through geothermal activity of the area, increased heating, and other events have caused it to be much easier to obtain this lithium. And the estimated, once everything is built up, the estimated production of lithium is around 600,000 tons, which is, of course, very important for the ever-growing electric car industry that's been building up, especially in California. So it'd be nice not to have to import lithium. Makes electric cars much cheaper. Some of the geology and effects of geothermal activity in the Salton Sea are there's large clay deposits across the entire thing, built up from the various mud volcanoes and other activity that's been going on there, since it was an old marine lake bed before it became a desert. Interestingly, there's some uranium found within these sediments in the grain. They are finely grained pieces of uranium, so much less, like 1/10 of a millimeter to much less than that, and they're only found within the clay matrices of the rock. However, this rock type has proposed some interesting ideas of radioactive waste disposal, since the salt is able to better contain the heat associated with radioactive decay and whatnot. Some seismic wave dispersion, which we did in class, shows it's only 20 kilometer deep crust within Imperial County, but more importantly, it's 10 kilometers thick for the northern part of the area. And this helps fuel sort of the geothermal activity, since the magma is fueling many of the processes and creating many of these mineralogical structures. Granitic xenoliths within rhyolite domes. When looked at, they show melting quartz, and melted, like melting along the boundary of quartz and feldspar. So they're not melting now, but they were melted, sort of welded together in a way. Suggests that the rock fragments of continental of basement rock. This suggests that these are in fact xenoliths, due to the fact that they were not made at the same time, and this is backed up by the idea of strontium isotopes, which we dated in class, since the granitic xenoliths are dated to a different time, a younger time than the rest of the rhyolite domes, which is the evidence. And that's it for this presentation, is the sources.